Hello, chemical systems. So today we're going to go over something called electronegativity. So I'll come back to that word in a second. You might recognize this simulation from a previous assignment. Here I have a sodium atom and a chloride atom. And if you remember, it's really atoms like to have an octet in their outer electron shell, which means that they'd like to have 8 electrons in their outer shell. They don't like more or less. It's got to be 8. It's just kind of the magic number for atoms. Unless you're dealing with hydrogen and helium, that's a different story. So you remember when we ionize the atom or atoms, sodium only had 1 electron, so it gives its electron to chlorine, which has 7, which would very much like to have 1 more electron. And now sodium and chloride both have 8 electrons in their outer shell. Now, since sodium gave up that atom, it is now gave up that electron, it is now positively charged. When chlorine took that atom, when chlorine took the electron, it became negatively charged because it has 1 more electron than it does protons. And this forms an ionic bond because now one atom is positively charged and one is negatively charged, which means they're attracted to each other. That's an ionic bond. So that's something we already went over. Now we're going to look at something called a covalent bond. A covalent bond remember with ionic bonds, very simply, an ionic bond is when an electron is taken or given from one atom to another. So the sodium atom gives the electron, the chlorine atom takes the electron. Covalent bond is when electrons are shared between 2 atoms. So for example, let's just start very basic. Here are 2 hydrogen atoms. Hydrogen atoms just have 1 proton and 1 electron. But they would both very much like to have 2 electrons in their outer shell. But they can't just grab any electron because that would make them a hydrogen ion. They don't want to become an ion, but they still want to have 2 electrons in their outer shell. So instead of donating and taking, what they do is they share. So this is called a covalent bond when so the hydrogen atoms are sharing their electrons. Here's another example with oxygen. Oxygen has 1, 2, 3, 4, 5, 6 atoms in its outer shell. Remember, most atoms would just love to have 8 electrons in its outer shell. So both of these atoms have 6 electrons in their outer shell, but they want to gain 2 more. They're not going to become ions when they touch each other. They're going to share their electrons. So now both atoms share 2 electrons and formed what's called a double covalent bond. We'll get into single and double bonds later. But now if I count 1, 2, 3, 4, this oxygen atom on the right has 4 of its own plus the 4 that it's sharing with the other oxygen atom. So it doesn't exactly have 8, but it's like it has 8. So it's happy now because it has 8. So hydrogen, oxygen, and this is the atom that we breathe in and out. When we breathe oxygen, we're breathing O2 molecules. So remember, when 2 or more atoms come together, it's called molecule. This is now an oxygen molecule. There's more than one type of oxygen molecule, but this is the kind that we breathe. This also happens with water. Remember, oxygen has 6 outer electrons. It would like to have 8. Well, look, it can share with hydrogen. When 2 hydrogen atoms come together, it makes H2O. Now it's this is a water molecule. So the hydrogen atom is happy because it has 2 electrons that's sharing with oxygen. This one has 2 electrons that's sharing with oxygen, and oxygen has a total of 8 electrons for those atoms that's sharing with the 2 hydrogen atoms. Or I keep on saying 4 of the electrons. Excuse me. I'm so sorry. These blue thingies are electrons, not atoms. Whew. Okay, so what we're going to look at today is what determines whether two atoms make a ionic bond or a covalent bond? Well, that all goes back to the concept called electronegativity. Let me type that out for you. You'll probably see it on today's agenda. It's called electronegativity. Defined, electronegativity simply means it's, oops, didn't think that was going to happen. It is how strongly atoms attract electrons. Remember, those valence electrons, the outer shell of the atom, are really what's responsible for all of the chemistry and all the bonding that's going to happen. So with this ionic bond, the chlorine atom is very good at attracting electrons, which is why it can take the electron from that sodium atom. But when you look at just two oxygen atoms, they have the same electronegativity. So even though the oxygen is very good at, has a very high electronegativity, it's not going to steal the atoms from one another. So how do we know what is going to make ionic and what's going to make covalent bonds? Well, that's why we have the periodic table. So the periodic table not only arranges atoms from lightest to heaviest, it also arranges atoms with certain trends. One trend, the trend that we're going to look at today, is called electronegativity. So I've shown you guys this PT table before. One really cool thing is it has lots of things I can click on the left. On the left side, I'm going to click on electronegativity, and it's going to show me this color graph. Just to make things easier to look at, I'm going to change these colors around a little bit. It's going to let me choose white. Okay, good. So now I have this set up. So atoms with very high electronegativity are blue, or sorry, elements with high electronegativity are blue, and elements with pretty weak electronegativity are white. I don't know if you're going to be able to read it on this video. Fluorine is the atom with the highest electronegativity, or excuse me, the element with highest electronegativity. Chlorine, sulfur, oxygen, those also have high electronegativity, but not quite as much as fluorine. And the way that this works is that electronegativity increases from left to right and increases from bottom to top, which makes fluorine the highest. And francium is one of the lowest. So francium has electronegativity of 0.7. So let's look at our first example that we chose, which is sodium and chloride. Sodium and chloride form an ionic bond, but how would we know that? By looking at electronegativity. So if it doesn't matter necessarily how much the electronegativity of a single element is. What you really want to look at is the difference in electronegativity between whatever two elements you're studying. So our first example was sodium, which is all the way over here on the left, and chlorine, which is over here on the right. So the general rule is that if the difference in electronegativity is 2 or more, then it will form an ionic bond. So let's just do the math here. So chlorine has electronegativity of 3.16. Sodium has electronegativity as 0.93. And if you're wondering why I got those numbers, those are just that once I click on electronegativity, it tells me at the bottom. And if you guys can't use this periodic table, if you're limited by your phone or whatever, you can probably just Google electronegativity of chlorine, electronegativity of sodium. You can look it up that way too. But if I just subtract 3.16 minus 0.93, 0.93 is almost 1. So that's a difference of more than 2.16, which is already more than 2. So I already have a difference of more than 2. So that's going to form an ionic bond. Let's look at an example of something that would form a covalent bond. So oxygen, hydrogen, that's water, right? We looked at the covalent bonds in water. Remember, covalent means that they're sharing electrons instead of just donating or taking electrons. Okay, so oxygen and hydrogen, Oxygen has an electronegativity of 3.44. Hydrogen is 2.00. So that's about, if I do that, I can do that in my head. I think I can. It's 1 point something. 1 point around, that's around 1.2. So the difference in electronegativity between oxygen and hydrogen is around 1.2, which is less than 2. So remember, if it's 2 or more, it's ionic. If it's less than 2, it's covalent. If it's around 2, it's kind of unsure. I'm not going to give you guys any of those examples. But since the difference between oxygen and hydrogen is less than 2 considerably, that those oxygen and hydrogen will form covalent bonds. In other words, they will share electrons rather than stealing electrons. Now, our other example is oxygen. Since oxygen and oxygen, well, they're both the same atom, they have the same electronegativity. So oxygen 3.44 minus 3.44 is 0. Well, that's going to form covalent bond because it's less than 2. So that one would be a really easy example. Now, will this work for every atom? In other words, can I bond any element from the periodic table to any other element? No, that's what this is saying. What this is saying is that you can use this electronegativity and use that rule of 2. If it's greater than 2, it's ionic. If it's less than 2, it's going to be covalent. Then that's a good way to tell what kind of bond is going to form. And here, let me go ahead and put that up there. Okay, so here's kind of a review of everything here. So for electronegativity between any 2 elements, if the difference of electronegativity between any 2 elements is greater than 2, an ionic bond will form. If the difference between 2 elements is less than 2, a covalent bond will form. And if it's around 2 or close to 2, we're not going to get into that. We won't study that. The elements may or may not bond. But yeah, we won't get into get that deep into the math or the physics between bonding. So we'll talk more about covalent bonds and double bonds, triple bonds, and all that fun stuff. And next week we'll get into diagramming bonds too. Hope this video helps you through today's material, and I will see you next time. Bye-bye.